reading this next problem through, it looks like a mixture problem. We're mixing 42-cent stamps and 50-cent stamps, so I'm going to use my mixture problem setup. Go back and watch my video on mixture problems if you have not done so yet. And I'm going to have 42-cent stamps, so 0.42 and 0.50. Prices and percents go on the top. She spends a total of this amount, $22.60, on 50 stamps. Now I'm going to make note that this was a total here on the top right. How many of each type did she purchase? We don't know. So that will be the X and Y we're trying to solve for. Okay, with that word total, I know that I'm going to go top times bottom plus top times bottom equals top and stop up there, but I also want to multiply through by 100 and move all these decimals to the right. So my first equation, top times bottom, is 42x. Second equation, 50 times y. And third will be just the 2260. My second equation is just plain old x plus y equals 50. Now I've got to make a choice on how I want to solve this, and I'm going to choose to keep the top equation as is and multiply the second equation through by negative 50 so that I can eliminate the y's here. So my system becomes 42x plus 50y equals 2260, and second equation, negative 50x minus 50y equals negative 2500. And adding down, we have the following. We have negative 8x equals negative 240, and so x equals 30. Now what is x? X is the number of 42-cent stamps. So here we go. X equals 30 of the 42-cent stamps. Now we need to find a y value to go along with. We know that x and y add up to 50, so y must be 20 of the 50-cent stamps. And that would then be our solution, and you can verify that everything works out so that she spent a total of $22.60. Now we have an airplane problem. We've got to see which method this is. Upon reading it, I'm looking for the speed of the plane and the wind. And in this chapter, we set up two equations with distance equals rate times time to solve this problem. Now both the trip and the return trip were 3,600 miles, so I'm going to write that down. And my rate, first time I was going with the wind, so I'm going to have R plus W for a total of 6 hours, and the return trip, R minus W, is against the wind for 8 hours. So we'd love to just have these R's and W's lined up, so I'm going to multiply or divide through, let's just say that, divide through by 6, and then the next one, divide through by 8. And this will give me 600 equals R plus W, and 450 is equal to R minus W. And adding down, these W's will cancel each other out. We will have 1050 is equal to 2R, and therefore R will be 525 miles per hour. We do know from these first two equations up above that the two speeds add together to be 600, and therefore 75 miles per hour will be the wind speed. Now we need to use row operations to solve this next problem. I'm glad to see that we already have a 1 in this top left corner, so everything is all ready for us to go when we write this augmented matrix. So the first thing we want to do is get a 0 beneath the 1 where that 4 is. To get that 0, we will multiply that first row by negative 4. So negative 4 row 1s plus row 2 will become the new row 2. So I'm going to rewrite my augmented matrix with the no changes in the first row, and that second equation will begin with a 0. Negative 4 times negative 3 is 12 plus 5, which makes 17. Negative 4 times negative 1 is 4, plus the 30 makes 34. Luckily, 17 goes into 34. We now would like to have a 1 where that 17 is, and we will create a 1 by multiplying through by the reciprocal. 1/17 row 2 will become the new row 2. So in our new matrix, the first row will remain unchanged, and the second row will become 0, 1, 2 by design. Now all we need to do is get a 0 where that -3 is, and that means we're going to take 3 times row 2, add it to row 1 to get the new row 1. Doing this will leave the second row unchanged as 0, 1, 2. You know the first equation will begin with 1 and 0, so all we really need is that one last position. 3 times row 2. 3 times 2 is 6, plus that -1 makes 5, and we can read off our solution set, which is 5, 2.